Hello, welcome back to the channel. I see more than 70% of you are not subscribed, so please subscribe, click the little bell icon so we can see each other more often. Welcome back to Greg Friedman's channel. I'm Greg Friedman. I'm here to review scientific manuscripts together with you, and this is for you. So if you have any questions or any ideas, please post them down below in the comment section. So let's get to this. Today, I want to talk to you about the topic that interests me lately, and that is CO2 emission control. I've been looking around to see who emits CO2, where do they emit it, how do they emit it, and who the biggest emitters are. And I stumbled on something I didn't think about before, so let's dive right in. So here we have a publication in Nature Sustainability. This is a highly rated journal, so you better be sure that the reviewers were thorough. Published in, or maybe they put it on the bottom. Let's take a look. Methods, so probably after methods. Oh, there we go. Received March 13th of 2020. And finally published about a year later on the 8th of March 2021. So let's take a look. The greenhouse gas emissions of indoor cannabis production. Haha, I didn't think about that. How much greenhouse gases does the cannabis production emit really? So let's take a look. A considerable amount of legal cannabis is cultivated indoors, primarily for quality control and security. Oh, security. So these authors take a look at the greenhouse gas emissions from the total life cycle of the cannabis production. The resulting life cycle greenhouse gas emissions ranged based on location from 2,200 to 5,200 kilograms of CO2 equivalent per kilogram of dried flower. Wow, that is not a small number. The life cycle greenhouse gas emissions are largely attributed to electricity, well, obviously, natural gas consumption for indoor environmental control, high-intensity grow lights, and supply of carbon dioxide for accelerated plant growth. Curious. So there's a whole bunch of stuff going on at those plants. In US, the legal cannabis industry has rapidly grown from 3.5 billion to about 14 billion in annual sales, with states like Colorado selling more than 530 tons of legally grown cannabis product every year. Tons. Just one state. I mean, granted, it's one of the first states to do that. The authors claimed that although the data concerning the exact amount of cannabis by cultivation method are not currently publicly available in the United States, a recent survey of producers in North America showed that 41% of respondents indicated that their growth operations occur solely indoors. 41% of cannabis is produced indoors. Curious. That's very interesting. The model that this paper utilizes analyzes weather from all over the United States, from 1,000 locations in US, and based on that does its predictions. Interesting. I guess it's a good model then. So in the next figure, which is probably the most important figure in this paper, they show cumulative greenhouse gas emissions for annual indoor cannabis cultivation across the United States, represented as kilograms of CO2 per kilogram of dried cannabis flower. Wow! So this map is pretty interesting. It's all weather dependent. So look, where the weather is more mild. And interestingly, Hawaii emits a lot of CO2 compared to California, for example. Didn't think about that. But the range is all over the place from 2,000 to 5,000. And if we look at natural gas consumption that's used for environmental control in a building, well, whoops, we're going for 67 megajoules per kilogram of dried flower in Hawaii. And I thought the weather is mild over there. Cool. And interestingly, electricity consumption is more in the hotter state. Well, I guess maybe that's air conditioning, but why not in Hawaii? Hawaii is mild weather. Anyway, here's the data, and data is king. As we can see, the resulting greenhouse gas emissions range 2 to 5,000 kilograms of CO2. For example, in Long Beach, California, seems to be the lower number, and in Hawaii seems to be the higher number, with median across the United States of about 3,658 kilograms of CO2 per kilogram of pot. Cool. Figure 2 breaks down the greenhouse gas emission based on HVAC heating and cooling, HVAC humidity measurements, grow lights, transportation, waste, CO2 used for the plant growth, which is, looks here, this is a pretty significant number. And also small dehumidifier, heater, air conditioner, nutrients, plant protection, soil. Big one here in Hawaii, for example, is HVAC humidity management. A very small heating and cooling. So it's very, very, very different based on location. It's not just, ooh, Hawaii is so mild and Florida is so hot. No, it also has to take into account the humidity of the place and everything else. Grow lights seem to be pretty significant everywhere, although they're different. So maybe, why is it more in Hawaii? I don't know, but this is data. In this work, the authors assume air supply rate of 30 volumetric air changes per hour. That's a lot. Here it is. For comparison, the recommended ventilation for homes is 0.35. I believe for office buildings like this one, it's like 6 or 7, something like that. And a hospital room require a minimum of 15. And these guys go as high as 60. Wow. Just wow. And air exchanges per hour. So clean air comes in, right? And used air goes out. What about all the smells? That's a recurring theme for me thinking about this project. What about volatile organic compounds? Smell. You're throwing out 30 to 60 volumes of a room, of a facility, per hour, every hour, 24 hours a day. What about all the smells? A lot of these facilities are inside of cities. Cool. Just an observation, I guess. And, the second most significant greenhouse gas emissions contributor observed universally is from high-intensity growth lights. Well, we sort of knew that, right? At least that's what I thought. But I didn't think about all the rest of these things, especially HVAC, which seems to be big chunk of stuff, much more than grow lights. But anyway, I digress. In all locations analyzed, indoor lighting requirements were held constant, and therefore the required annual kilowatt hours of electricity are constant. That makes sense, actually. So plants need certain number of photons per square foot. It makes sense. So all of the plants are receiving pretty much the same lighting. Why does it differ by state? I don't know, maybe they put a glass roof and use additional energy from the sun? Possibly, maybe that's a solution for Hawaii to reduce energy use from the lights. Hawaii, isn't it always sunny? Every time I go there, it's sunny. But then I only go there when it's sunny. Something to think about. The results presented in the figure that we just looked at indicated that more than 80% of greenhouse gas emissions for those locations are generated by practices that are non-traditional for agricultural products. Traditional agriculture cropping systems typically see the largest greenhouse gas emissions from practices associated with land preparation and management or from fertilizer. But indoor cannabis, these values on average less than 5% of the total. So less than 5% is from traditional agriculture. The rest is everything associated with being indoors. I didn't think about that. The significant energy required to create an artificial climate indoors for the plants causes cannabis to be extremely greenhouse gas emissions intensive. So it's because it's indoors. Why don't we move it outdoors? Like security, people are going to steal it. It's tricky, this business. Certainly tricky. Well, maybe we could switch to light emitting diodes, LEDs. Those are good, right? But they cost more and they use precious metals that need to be mined. We could also commit to using high efficiency HVAC equipment. That one actually makes the most sense for me. If you want to dive into the details, read this paper yourself. Of course, I will leave links in the description to all information about this paper and where to find it. But the conclusion that I see from this is we need to improve lighting system, air recirculation systems, higher efficiency HVAC to reduce greenhouse gas emissions from this industry. And now that it's legal, they're not gonna stop smoking it. That one's not going away. We might drive Teslas or Rivians, but we're not gonna stop smoking pot. I'm a beer drinker myself, but I don't judge, and it's legal. Air exchanges going from 10 to 60 can result in greenhouse gas emission difference of more than 230%. So maybe we can circulate air a little more efficiently. Let's think about that one. So the authors conclude that air handling in these facilities warrants particular attention while developing best management practice guides. Air handling, humidity control, air exchanges per hour. Again, my question is, how do you deal with the smell, especially if the facility is inside of a city? I don't know. And anyway, it's regulated, so federal restrictions limit the transport of cannabis across states. Therefore, a US-wide geographic optimization is not possible. So we can't just move it to the best state for it to grow. Gotta manage it. And when it becomes legal everywhere, it has to grow everywhere. Fantastic. The authors look into these geographic variations, especially there in Colorado. And even in Colorado, there is a big difference between one town and another town due to elevation, due to all sorts of things. And based on that, authors suggest that each individual state, we can't transport across the border of each individual state, but the state within itself, like Pennsylvania is huge, so we can model and optimize location for these facilities to significantly reduce greenhouse gas emissions. That's a good idea, especially for politicians. Incentivize growers to grow in locations where that would offer the least greenhouse gas emissions. So in conclusion, the authors reiterate that more than 80% of greenhouse gas emissions from all indoor cannabis locations that they looked into are caused by practices directly linked to indoor cultivation methods, specifically indoor environmental control, high-intensity grow lights, and supply of CO2 for increased plant growth. If indoor cannabis cultivation were to be fully converted to outdoor production, these preliminary estimates show that the state of Colorado, for example, would see a reduction of more than 1.3% in a state's annual greenhouse gas emissions of 2.1 million tons of CO2. These greenhouse gas emissions are on par with the entire sector within the state, such as coal mining, about 1.8, waste management, about 4.2, and industrial processes, about 4.5 million tons. This last statement kind of blew my mind. So, cannabis indoor growth produces greenhouse gas emissions comparable to coal mining. Let that sink in. Alright guys, please subscribe, click the little bell icon, and definitely please leave negative or positive comments in the comment section below. I love reading them. I try to address all of your concerns, try to answer your questions. Feel free to email me. So anyway, thank you for watching, and I'll see you next time. Take care.